Our next segment on fluid statics is the barometer. A barometer, what is that? Well, it meters something. It measures something. So the word meter means measure, and the word bar means pressure. So a barometer is actually a pressure meter. And the very first one that was ever built was built by Torricelli in the 17th century, way back in Italy. And the way he did that, and actually it's an experiment that has been repeated many times, and that was even done by my physics professor when I was in high school, which of course nowadays is a big no-no, but because it involves mercury. So what you do is you take a little dish, you fill it up with mercury, and then you take a glass tube that's long enough, at least 4 feet long, or 3 feet would be enough, and you turn it upside down and you fill it with mercury. Then you put your finger at the very end, you turn the tube around, and you place it inside the little vat here with mercury, and then you let your finger go, and the mercury will drop to a certain point and stay there. And then you'll have what we call a column of mercury inside the tube, and at the very top of the tube there's simply a vacuum. There's no air there, so zero pressure at the very top of the tube. And it turns out that the atmospheric pressure, which is what you're trying to measure, can be determined by the height of this column. And let's see how that works. So what we can say here is at this point right there, that the pressure caused by the height of the mercury equals the pressure of the atmosphere. So at this location right there, we can say that the pressure due to the mercury is equal to the pressure due to the atmosphere. And that's, after all, what we're trying to measure. So how do you get the pressure of the mercury? Well, that's found in the very same way as saying what's the pressure inside a pool. And so we can say that the pressure is equal to rho GH or rho GY. And the density of mercury is, let's not plug that in yet at this moment. So we can replace this by rho GH is equal to the atmospheric pressure. And so what that means is we need to find the H for that. And so that means that H is equal to the atmospheric pressure divided by rho times G. And of course, then Torricelli was trying to find the atmospheric pressure, and of course he measured the height and then from that figured out the atmospheric pressure. What we're going to do is the other way around. We're going to find the height of that mercury column that gives us the measurement for the atmospheric pressure, knowing already that the atmospheric pressure is 101,300 newtons per square meter. So we divide that by rho. The density of mercury is 13,600 kilograms per cubic meter, which is 13.6 times as dense as water, and we multiply that times 9.8 meters per second squared. And when we do that, we get the height of that mercury column. So let's calculate that. 101,300 divided by 13,600 and divided by 9.8. And it turns out it is equal to 0.76 meters, which is 76 centimeters, which is 760 millimeters. So if you do this experiment, the column of mercury will take up a height of 76 centimeters, which is about 2.5 feet, maybe about like that, and that would then be a measurement of the atmospheric pressure. We can also express that in terms of millimeters, and it turns out that the initial unit for pressure was torrs from the famous physicist Torricelli, and so 1 atmosphere was equal to 760 torr, indicating the number of millimeters of a mercury column you would need to measure the atmospheric pressure with. So that was the very first barometer, or the very first pressure meter build that uses this principle as pressure caused by a column of fluid, and then setting that equal to the atmospheric pressure and calculating the height of the fluid that way. Very clever idea. And of course, nowadays they don't let you do that anymore because mercury is kind of a nasty material. You don't want to breathe in the mercury vapors. You want to stay away from it. So unfortunately, we no longer do that in the classroom today. I don't, because I want to keep my job. All right, and that's how you do that.